process with in different ways. And once again, thanks for being my course instructor for this course, um, Advanced Operating Systems. And when it comes to the presentation, today I am going to present about the paper called A Novel Programming Model for Distributed Systems. In this paper, the authors proposes a new programming model for distributed systems that aims to simplify the process of development process. The paper begins by discussing the challenges of developing the distributed systems, such as the need for security and correctness, as well as the need for high performance. The authors then introduce the concept of predictive programming, which is way for making decisions in distributed systems by using the predictive model of system and its environment. And the authors also argued that the predictive programming can be help to simplify the distributed development of the process by offloading responsibilities of making decisions from the application to the runtime system. And they also have given the many techniques, and they have the others also do many research for simplifying the distributed system development in different ways. Let's discuss them in and once again, thanks for being my course instructor for this course. When it comes to the challenges of advanced operating systems, distributed systems, when it comes to the first challenge today I'm going is the complexity in distributed systems. Distributed systems are made up with many different components. Each will have their own behavior with their own with the own potential of the failure. This will make the designing the distributed systems very difficult, and along with the design and it is very difficult to implementation and testing it too. And the second challenge is the heterogeneity in the distributed systems. And distributed systems often consists of different types of computers, the operating systems and software, and this can make it difficult to ensure that all the components in the systems will work together correctly. And the third challenge that we face is fault tolerance in the distributed system. The distributed systems are also susceptible for failures, as distributed systems have many components. They should be in sync with each other, so there are high chances of getting failed. If one system fails, there are high chances of entire system will get fails, because the fault tolerance is very important when designing the distributed systems. And the fourth challenge that we face is security in distributed systems. When it comes to the security things, as we have to maintain many systems, we have to be very cautious in monitoring security for all the components across the systems. As the security, if any data loss from one system, it can impact very huge. But when it comes to the monolithic systems, when compared to monolithic systems, it will provide the larger surface for the security attacks. This is why we have to be very careful when it comes to security terms in the distributed systems. And the fifth one is about the scalability. And scalability is a term which is very important for the present world, because the amount of data is getting increasing daily. To meet up all this demand, every system should be very the system should be very scalable, and this to make system very scalable, from the design point itself, it should be very optimized, so that we can develop a system that can be very scalable. Even though if we got very huge load in the system, we have to see we can able to system to not to break. And as in distributed systems, if any particular system got very high amount of weight, then it will cause issue to the entire system, and entire system might break. So we have to be very careful when it comes to the scalability also. Okay, now let's deep dive into the security things. uh, uh, let's deep dive into the techniques for developing the distributed systems. Here there are five techniques for developing distributed system to make the distributed system uh, to make the process to make the distributed system work as expected. The first one is abstraction, and second one is modularity, and the third one is composition, and fourth one is replication, and the fifth one is tolerance. And when it comes to the abstraction is the process of hiding the complexity of the system from the user. This can be done by providing the simplified view of the system, and that is easier to understand and use. In distributed systems, abstractions can be used to hide the details of the underlying hardware and networking infrastructure. This allows developers to focus on the business logic of the system without having worry about the details of how the system is implemented. And the second one is modularity. The modularity is the process of breaking down a system into smaller independent components. This makes the system easier to understand, develop, and maintain in distributed system. Modularity can be used to break down the system into different modules, each of which is responsible for the specific task. This makes easier to develop and maintain the system. If any one module got affected, and other ones won't affected. And third one is composition. Composition is the process of combining different modules to create larger systems. This also develops to create complex systems by combining the simple well-defined modules. In distributed system, composition can be used to combine different components to create a larger system. This allows developers to create a system that are tailored to specific needs. And the fourth one is replication. The replication is process of creating multiple copies of a system component. This can be done to improve the availability and fault tolerance of the system. In distributed system, replication can be used to create multiple copies of server or database. This makes system to be more available. And if one server or database fails, the others will be still be used. But when it comes to the replication system, we have to be very cautious in maintaining data across all the replications unique. There are high chances that there might be data mismatch among the systems, and we may get the false data when false data if we have access if we are trying to access data from the other database. And the last one is the fault tolerance. Fault tolerance is availability of the system to continue to operate even in the presence of failures. This can be achieved by using the technique called replication, redundancy, and error detection. In distributed systems, the fault tolerance is very essential as the failures are unavoidable. By using the fault tolerance techniques, distributed systems can continue to operate even if some of the systems are failed. Okay, in this slide, let us see the benefits of abstraction in distributed system. Here, when we are using abstraction, uh, the, uh, the readability in the distributed systems will get increased, and this also reduce the complexity in the distributed system, as every module has maintained its own responsibility. It will be also easier to track things if anything went wrong, and it's also increase the flexibility in distributed system. If some of the module was not working as expected, we can easily replace this module with other module instead of trying to go through the entire code. So uh, it, uh, here the abstraction is very useful in the distributed system. Here are some examples for the abstractions for distributed systems. Here we have shown the 5 examples. The first one is remote procedure call, the second one is message parsing interface, and third one is object request broker, and the fourth one is distributed component model, object model, and fifth one is web services. When it comes to the remote procedure call is a way of calling a procedure in another process as it were the local procedure. This is done by sending a message to remote process, which then executes the procedure and returns the result. The remote procedure call is popular technique for building distributed systems as it allows developers to write the code that is unaware of underlying network infrastructure. And the second one is message passing interface. The message passing interface is standard for message passing between processes. It is more low level abstraction than RPC, and it gives better control for developers over the communication between the processes. The message processing interface is often used for high performance computer applications as it provides better performance than a remote procedure call. And the third one is object request broker. Object request broker is a middleware that provides distributed object model. This allows developers to create objects that can be accessed from the processes of the network, and the object request models are often used for the building distributed systems as they provide high level abstractions for the developers. In object request broker, uh, the developers can build applications very easily when compared to the remote procedure call and message passing interface. And the fourth one is distributed component object model. The distributed component object model is developed by the Microsoft that provides the distributed object model and it is similar to the object request broker, but it is designed to work on Microsoft platforms. And this distributed component object model is often used for building distributed applications on Windows. And the fifth one is the web server. The web servers are a set of standards that allow applications to communicate with each other over the web. They are based on XML and HTTP, and they can be used to build a wide variety of distributed applications. The web services become increasingly popular as they allow developers to build applications that are accessible from everywhere in the world. Now let's discuss about the modularity in distributed systems. Dividing a distributed systems into smaller and independent modules is called the modularity, and each module can be developed and maintained independently so that if it will be easy to figure out if there are any issues, and it makes distributed system to be more flexible and scalable. Next, let's discuss about the composition. The composition in distributed systems is combining the smaller and independent module to create larger and most complex distributed systems, and it allows for reuse of modules and makes the distributed system to be more flexible and scalable. Let's discuss about the terms scalability, availability, and flexibility. The scalability can help to scale the distributed system by allowing them to be easily expandable by adding new components. And when it comes to the availability, the composition can be helpful in improving the availability of distributed systems by providing the redundancy. If one component fails, the other can continue to operate. And third one is flexibility. The composition can help to make distributed system more flexible by allowing them to be easily adapted to changing requirements. Next let's discuss about the replication in distributed systems. Replication is the process of storing multiple copies of data in different locations, and this can be done to improve the availability and fault tolerance in the systems. In distributed systems, replication can be used to create multiple copies of the server or database. This makes system to be more availability as one server or database fails, the other can be still be used. There are two main types of replications in distributed systems. One is active replication and other is passive replications. In active replications, all replicas are active and can be used to service requests. This provides the highest level of availability, but it also requires more complex coordination between replicas. And when it comes to the passive replications, only when one replica will be active at a time, and the other replicas are passive and are only used if the active replica fails. This provides low level availability, but it is simpler to implement and it is also very cost effective when compared to the active replications. These are the factors that need to be considered while designing the replication systems. They are the type of data that is being used for replication and the availability of requirements of the systems, the cost of the replication and the complexity of the replication system. These are the things about the replication in distributed systems. And the next one is the fault tolerance in distributed systems. The technique of detecting and recovering the failures in distributed system is called the fault tolerance. And we have to check these four things called replication, checkpointing, recovering blocks, and consensus algorithms. Replication is process of storing multiple copies of data in different locations. This can be improved the availability of fault tolerance of the systems. Checkpoint is the process of saving the state of distributed system at particular point of time. So if any failures occur, we can come back to the particular point so that the loss will be minimal. And third one is recovery blocks. Recovery blocks are techniques for ensuring that the state of distributed system is consistent after a failure. And the fourth one is consensus algorithm. Consensus algorithms are set of algorithms that can be used to ensure that all the components in the distributed systems agree to a statement of the system. Here in this consensus algorithms, there will be some certain of rules so that every system in the distributed system works perfectly with when they have to work. So this consensus algorithms is very important in the it comes under the fault tolerance, which is very important. And let's discuss about the security in distributed system. The techniques for protecting distributed systems from unauthorized access, modification, and destructions, and these are authorization, authentication, encryption, and intrusion detection. And when it comes to the authorization is a process of verifying the identity of the user or the system. It is typically done by requiring the user or system to provide something like password or some keys uh, such as tokens. And the second one is authorization. Authorization is process of determining what the user or system is allowed to do. This is typically done by assigning permissions to users or systems. And the third one is encryption. Encryption is process of converting data into the form that can be read without a key. This is used to protect data from unauthorized access. And the fourth one is intrusion detection. Intrusion detection is a process of identifying and responding to unauthorized attempts to access a system. This is typically done by monitoring system logs for suspicious activity. Now let's discuss about the scalability in distributed systems. The techniques for increasing the scalability in a distributed system are replication, load balancing, caching, and sharding. Replication is process of creating multiple copies of data. As we discussed above, here we are creating the multiple copies of data for the fault tolerance and to improve the availability. And the second one is load balancing. Load balancing is a process of distributing workload across multiple servers. This can be used to improve the performance of the system. If some 30 requests came at a time and server is capable of handling only 10 requests, maintaining parallelly 3 or 4 servers and distributed those requests among these servers is very important. And here the load balancing will be working for that case. and the third one is caching. Caching is the process of storing the frequently accessed data in memory, which can be accessed very fast. This can improve the performance of the system by reducing the number of times the data needs to retrieve from the disk. And the fourth one is sharding. Sharding is the process of dividing the very big amount of data to small data, and they are called shards. And this will improve the scalability of the system by allowing it to scale out horizontally. Instead of working on some TBs of data at a time, it will be easier for system to work on small amount of data, and as multiple systems will be working on the same data, um, the work will be done very fast when compared to uh, processing entire data at a time. Here are some findings and outcomes of the paper, and the findings are: the distributed systems are complex and challenging to development. uh, there are number of techniques to simplify the processes in the distributed system. There are techniques like abstraction, modularity, composition, replication, checkpointing, recovering block, construction algorithms, authentication, authorization, encryption, intrusion detection, replication, load balancing, caching, and shading. And this article has made it easier for me to understand the difficulties involved in creating distributed systems, as well as proposed programming approach that could streamline the process. The paper also helped me in understanding the research implications of the study for the future, such as need for additional studies on building predictive models and distributed system runtime systems. I think the proposed model and the distributed system runtimes, I think, uh, are very well strategy for streamlining the creation of distributed systems. The concept can lead to less complex source code and better functionality, and increasing robustness. But the model can be used in real systems. Several hurdles must be come over. Uh, the study will have an impact on my future practices, as it makes me more aware about the difficulties of building the distributed systems and possibilities of proposing programming models to simplify the building process. I look forward for the following studies in this area and that are created and used. The decoupling of application from runtime system is original development process. Answering the options using the predictive model is promising method in increasing the performance and robustness in distributed systems. And the initial implementation of the model was successful and showing good performance and robustness. Overall, this article was thought provoking and educational. I think proposal programming model is a good strategy for streamlining the creation of distributed systems, and to see how it evolve be put in future practices. There are some outcomes from this paper. By using the above mentioned techniques, developer can create distributed systems which is very reliable, available, and scalable. These systems can also be easier for understand, development, and maintain. And there are some future research directions, like if there are any new abstractions for the distributed systems, or new techniques for simplifying the distributed systems, or any new methods for ensuring the correctness in distributed systems, and any new ways to improve the performance of the distributed systems. These are the future research directions that I think we should work. And in this paper, the results indicate that the additional research is needed to create a predictive model in distributed systems. It is unclear whether the prediction model is used in the study would be accurate enough to make wise decisions in real systems, as it is not yet fully developed. The results of the studies also indicate that more research is needed on how runtime systems are implemented for distributed systems. and it is not clear whether runtime systems used in the study would effective enough to make quick judgments, as it is not well developed. And there are some questions that raised into my brain, and one of that question is, what are the usability implementation of proposed programming model for the developers? And these I think these made me to feel these are the future research directions. When it comes to the conclusion, the distributed systems are complex and challenging to development. They are made up with large number of components that can interact in complex way. This complexity can make it difficult to design, develop, and maintain the distributed systems. There are number of techniques that can be used to simplify the development of distributed systems. These techniques include abstraction, modularity, composition, replication, and there are so many like recovering blocks, construction algorithms, authorization, authentication, encryption, introduction, replication, load balancing, caching, and sharding. By using these techniques, the developers can create distributed systems that are more reliable, available, and scalable. And these systems can be also be user easy to understand, development, and maintain. And these are the references that I have referred and also mentioned in the paper that I have gone through. And thank you for giving opportunity to present this information and letting me to research about these things.